Hello friends, here we are going to start with the methods of dimensional analysis. There are two methods of dimensional analysis, Rayleigh method and Buckingham Pi method. In this video, we will see the Rayleigh method and we will see the Buckingham Pi method in the next video. So let us start with the Rayleigh method. This method of dimensional analysis was proposed by Lord Rayleigh in 1899 for determining the effect of temperature on the viscosity of the gas. In this method, a functional relationship of some variables is expressed in the form of exponential equation which must be dimensionally homogeneous. Here, thus if capital X is some function of variables x1, x2, x3, dash 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 xn, the functional equation can be written in the following general form. Capital X is equal to function of x1, x2, x3, dash 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 capital Xn. This is our equation number 1. In this equation, capital X is a dependent variable, while x1, x2, x3, dash dash xn are the independent variables. A dependent variable is the one about which the information is required, while independent variables are those which govern the variation of dependent variables. The above noted equation may be expressed as capital X is equal to C into x1 raised to A, x2 raised to B, x3 raised to C, x4 raised to D, dash dash dash, xn raised to small n. This is our equation number 2, in which we have C is our dimensional less constant, which may be determined either from the physical characteristics of the problem or from the experimental measurement. Also, the exponents a, b, c, d, e, dash 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 small n are then evaluated on the basis that the equations is dimensionally homogeneous. The dimensionless parameters are then formed by grouping together the variables with the least powers. The method is now illustrated by means of an example. So let us start with the example. Consider the problem of fluid flow through a small orifice discharging freely into the atmosphere under the constant head. Orifice is a hole or opening, especially in the flowing body like pipes. This is the orifice. So let Q be the discharge passing through a small orifice of diameter small d under the constant head capital H. Also, rho is the mass density and mu be the dynamic viscosity of the fluid flowing through an orifice. The discharge Q may be assumed to depend on these variables small d, that is the diameter of orifice, then capital H, that is the constant head, rho is the density, small mu, that is our dynamic viscosity, and g is our gravitational acceleration, since the flow is freely into the atmosphere. Therefore, the functional relationship for Q may be written as Q, that is the discharge, is equal to the function of mu, rho, small d, h and g, which by the Raleigh's method it may be expressed in the exponential form as Q is equal to C into mu raised to A, rho raised to B, small d raised to C, capital H raised to D and small g raised to E, where C is our dimensionless constant. By substituting the proper dimensions for each variable in this exponential equation in the form of MLT system is as for the discharge Q is, that is we have a unit of discharge, it is meter cube per second, that is length raised to 3 upon time. This is for the discharge. For the constant C, we have m raised to 0, l raised to 0 and t raised to 0 because the constant is dimensionless quantity. Then we have mu, that is dynamic viscosity. It has a dimensions as m upon lt raised to small a. That is a is our exponential component. Then for the density rho, we have a dimension as m upon l cube raised to small b. Then we also have diameter of orifice is a single quantity, that is L, and for the constant head we have a dimension, that is L raised to d. And last one is the gravitational acceleration. For this we have a dimension L upon t square bracket raised to e. By For the dimensional homogeneity, the exponents of each dimension on the both sides of the equation must be identical. So, by equating the left hand side and right hand side, the quantity of m, l and t, we have for m 0 is equal to a plus b, for l 3 is equal to minus a minus 3b plus c plus d plus e, and for t minus 1 is equal to minus a minus 2e. By equating the raised to term from the left hand side and right hand side, since there are 5 unknowns in the 3 equations, 3 of the unknowns must be expressed in the terms of the others. So we have small b is equal to minus a by from equation 1, that is for m we have b is equal to minus a, e is equal to 1 by 2 minus a by 2 and c is equal to 5 by 2 minus 3a by 2 minus d. By substituting the value of b, e and c in the equation of q, we got the final result as, see here, this one is the last result, in bracket a in square root 2gh and function of, that is f1 of mu upon rho d raised to 3 by 2 g raised to 1 by 2 into h by d and square bracket completed. Here we have the expression as q is equal to cd into a in square root of 2gh. Here small cd is the coefficient of discharge of the orifice, which can be expressed as cd is equal to f1 of mu upon rho d raised to 3 by 2 g raised to 1 by 2 into capital H upon small d. Here we have cd as it is. It may be pointed out that the both of the terms in the bracket are dimensionless and cd also a non-dimensional factor. Here is a Rayleigh method of dimensional analysis. Thank you.